You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Daniel Whiteson. Daniel Whiteson is a particle physicist and professor of physics at the University of California in Irvine, whose work explores the fundamental building blocks of the universe. Using machine learning and advanced statistical techniques, he studies high-energy particle collisions to probe the true nature of matter and energy. He also co-hosts the popular podcast Daniel and Kelly's Extraordinary Universe with Kelly Weinersmith, where the pair dive into the wonders of the cosmos. He is the co-author of his new book, Do Aliens Speak Physics? A thought-provoking look at how intelligent civilizations might communicate through the shared language of physics.
Dr. Daniel Whiteson, welcome back to the program.
Thanks so much for having me on, and for having me on to talk about aliens, my favorite topic.
We are definitely going to dig deep into the aliens, but let's first ask the big question.
Ooh.
Do aliens speak physics? The title of your book that you have coming out very soon. When is this book out? And then let's get into the minutia of Do Aliens Speak Physics?
Yeah, so this is my new book, Do Aliens Speak Physics. It's out November 4th, and it's a lot of fun. It asks what it would be like when aliens arrive. Could we talk to them about the secrets of the universe, or might aliens be doing physics in a very different way than the way we're trying to explain the universe?
Well, our big problem is that we only have a partial understanding. If you got a complete understanding, your perspective might be a little bit different. However, I would advance this idea. If an alien doesn't speak physics compatible with our own, it might not be able to build a radio telescope and even see us, and it might not be able to build a civilization we could see that produces a recognizable technosignature that we could decipher and understand what we're seeing. So is it possible that there is indeed a commonality about physics and perhaps mathematics even, and that's a sticky topic, but could it be that in order to detect another alien civilization, with us being someone else's aliens, you need some kind of understanding of physics?
It's possible, and I think that's the most likely scenario. But in this book, I wanted to ask whether our assumptions and our guesses were really more than that, if they were necessary, if it's required, for example, to think about the universe the way we do in order to develop technology, or if that's just the way that we imagine it and aliens might be very surprising. So concretely with your question, do you have to be scientific in order to develop technology to communicate with radio waves across the stars? I don't think that's absolutely necessary. I can imagine an alien culture where electromagnetic communication is natural to them, it's intuitive. You know, maybe they communicate with each other using some sort of electromagnetic radiation. Frankly, I don't know why we don't. I mean, we have neural systems that rely on electromagnetism. Why don't we have like intuitive, natural radio waves communicating between brains? Anyway, if they develop this kind of technology, they might naturally also develop ways to amplify it, and then we might pick up on those signals. And so there could be aliens out there that are intelligent, that are speaking to us in electromagnetic waves, but aren't scientific. Maybe they don't care. Maybe they're not curious the way that we are.
Well, they may wonder why would we engage in it? If you have an intuitive understanding, then you don't have to engage in science, which is obviously the exercise of trying to figure it out. Now, about sensory questions. You in the book point out that what if they can smell a photon, or their senses are so completely different from our own that we wouldn't understand them, that there would be no commonality of sensory input.
Yeah.
Go into that.
Yeah, I think it's a really interesting question, how we imagine the universe. Like, number one, we feel like the way we imagine the universe, I feel like I'm sitting in my office and it's giving me an impression of what's really out there. So we have this sensorium, which feels really rich, like a revelation of reality. But we know that it's not. We know that there's a lot out there that we are not perceiving. The universe has so much more going on, and not just that there are different frequencies of light or that there are crazy particles out there that don't interact with us like neutrinos or dark matter. There's a lot going on in the universe, like things happen on really fast time scales or really short time scales that we have trouble thinking about. So we have sort of a particular way of thinking about the universe. And I think that limits the way we imagine the universe, and it defines sort of like our sensorium or like our umwelt about how the universe works. And that's important because all of our physics, as you say, is satisfying our curiosity. It's translating the unfamiliar into the familiar. And so our senses define what's intuitive, what makes sense to us. Let me give you an example. The photon. What is it? It's some weird quantum object. We try to describe it using our intuition, our experience of balls and waves. And so we say sometimes it's a particle, sometimes it's a wave. The reality is that it's not sometimes a particle and a wave. It's some new weird thing we can't ever fully capture with our intuitive language, but we try. And so if we're only perceiving a slice of the universe, there's a lot out there we're not perceiving. And even if we can develop technological eyeballs like the James Webb Space Telescope to see in the infrared, we're always translating that back into our kind of experience, to our intuition. And so aliens out there, they might have a very different set of senses based on the evolutionary history that they experienced. So they might have a very different intuition, a different language that they want the universe explained to them in. And if those two things don't align, then our explanations might be very different. Imagine, for example, microscopic aliens that are very naturally understanding quantum mechanics because they perceive photons before they've collapsed and they can interact with them in that way. And so quantum mechanics isn't weird and difficult. Instead, classical physics is, or something else is, and they have a different sort of natural basis of thought. This is the kind of exercise I really enjoyed in the book, thinking about how our assumptions might be different and might be colored by our humanity, so that when aliens arrive, they might be thinking about the universe in very different ways, asking different questions and accepting different kinds of answers.
Got a crazy question for you, Doctor. Now, you're a physicist, and we are very much, perhaps even painfully aware that we cannot see most of the universe, and that it is made up of dark matter. Can that be an entire domain? Is it possible that that is a domain that has its own organisms, and for them, the photon is illusory in the same way that we see dark matter?
Yeah, I love this idea. It certainly is possible. Currently, we know a lot about dark matter. We know that it's out there. We know how much of it is. We know roughly where it is, but we don't know what it's made out of. It's still an open question. Is it a particle? What kind of particle? Is it just one particle? And we've never seen any kind of interaction of dark matter that's not gravitational. So currently, the only thing we know is that dark matter feels gravity, and it doesn't feel any of our forces. But there's so much dark matter that it seems sort of overly simplistic to explain it in terms of one kind of particle that doesn't feel anything but gravity. That might be the scenario, but it might also be that dark matter contains multitudes, that there's mostly some sterile thing that only feels gravity, but some component of dark matter could be more complicated. It could have its own kind of self-interactions between different kinds of dark matter particles. I mean, our kinds of particles, there's many different particles that make up our complex experience. And so it's possible that dark matter also has many particles with many interactions, which could lead to dark matter physics, dark matter chemistry, maybe even dark matter biology and dark intelligence. So there's so much dark matter out there that there's room for lots of weird stuff to happen. And yeah, including dark matter beings. And what would it be like for them to experience the universe? What questions would they have? What things would they find fascinating or interesting or confusing, right? Could we come together with our understanding of our kind of matter and their understanding of their kind of matter to some sort of harmonious conclusion? Or would they not even be interested in our tiny little irrelevant slice of the universe?
It's interesting because the ratios, there's so much more dark matter to account for the gravitational effects that we see.
Yeah.
But at the same time, we benefit from one thing, the neutrino. It basically is dark matter. So we know about one kind of particle. There's just not enough of them. So do you favor a particle nature for dark matter? And it can be many different particles. As you know, the standard model just expands as far as particles. You can go all over the place and invent particles. So that's what you foresee, is that if we ever do crack dark matter and we find out what it generally is, do you foresee it getting a whole lot more complicated from there?
Yeah, so neutrinos are fascinating because they're a lot like dark matter in that they don't interact very much, but they do interact via the weak force. So scientists wondered for a long time whether neutrinos were the dark matter, but it seems like now neutrinos sort of move too fast. They're a little too hot to explain everything out there. So there's definitely a component of dark matter that isn't neutrinos. And yeah, it's a great question. What is it? And naturally we imagine, it's got to be another kind of particle. Why? Because so far, every kind of matter we've seen is particles. But as you say, our kind of matter is a tiny little slice of the universe, and it's very dangerous to extrapolate from the kinds of things we've seen that we know are not representative to the rest of the universe and to impose the same framework. That's exactly what I was worrying about in this book, is wondering how much of our little unusual experience has colored the whole project of physics in a way that when aliens show up, they might be like, wow, y'all went down the wrong path completely. I mean, we understand why, but here's the better way to think about it. It's possible that dark matter isn't made of particles. It's made of something else entirely weirder than we've imagined, some kind of matter that isn't broken into pieces, that's like smooth and continuous, or something else we can't even grok because, we've never had the experience of it. And that would be the best case scenario. Some people might imagine, I hope the aliens show up and they're doing physics the way that we do it, and they just sort of launch us forward into our scientific future and tell us the answers to all the questions. And yeah, that would be wonderful, but it would also be sort of like traveling to another country and discovering all the coffee shops are just Starbucks, right? Well, it'd be disappointing because you travel in order to have your mind expanded, to learn about new ways of living and being. So my favorite scenario is that the aliens come and they don't do science the way that we do it. They do it in some other weird way, or they ask questions we never even imagined, or think about science in a different way, or don't use mathematics. I really want our minds to be blown when the aliens come, because that's the moment of learning, right? When your assumptions are upended. And the greatest moments, I think, in physics and history are times that we discover the universe was contradicting our assumptions. No clocks don't run the same way everywhere, for example, or no things at a particle level are not determined in terms of location and velocity. Those things were difficult to absorb, but they were deep lessons about the nature of reality. So my personal fantasy is the aliens come and they blow our minds about the way the universe works and the way that science can be done, in a way that tells us about the human lens that we've put onto our physics.
Now, when thinking about this, and you tackle this in this book, but the question is that we have enough trouble communicating between groups of humans.
Yeah.
Language is not always overlapping, and how you think about language is not universal to all humans. Everybody's got their own ideas.
Yeah.
And in an interconnected world as we have today, that's different. But 500 years ago, it was hard. If you have no commonality at all, you're basically pointing at stuff and saying, I call this, and then they say, well, they don't, they're like, well, it's something different to me, which gets into cultural stuff. So the question is that, do you have any hope that if we ever got an alien radio signal, we would even begin to be able to decipher it? And I know this weighed on Frank Drake heavily, that, what if they work on a different time frame?
Yeah.
What if they think once every 1,000 years and that's normal to them, or something like that? Well, how do we weed through this?
Yeah, it's a hard problem. And I'm a big supporter of SETI. I love it. And I think they should keep doing it and we should spend more money on it. But I do worry that the project might be impossible, that we can't tell if we've gotten an alien signal, or that even if we luck out and get a signal which is clearly artificial, that we have no chance of basically decoding it. Because think about what it means to decode a signal. Somebody has taken an idea and they have encoded it. They've translated it from some pure idea form in their alien mind into something that can be transmitted. Maybe they scratched it onto a plate and put it on the Pioneer and sent it to us, or they encoded it in binary or some other kind of encoding. But there's always that step where you take pure ideas and you translate them into some kind of symbol. And that translation is always arbitrary and cultural. There's never a case when you can just look at the symbols and intuit the ideas perfectly, where there's no other way to interpret them. And we've tried this, like Frank Drake and Carl Sagan. They designed the Pioneer plaque. They put it on the Pioneer in the hopes that if aliens ever saw it, they would get some sense of how humans think. And, they did a great job. I don't mean to criticize them. And I think also they were just given 2 weeks. So what they came up with is pretty good. And of course, they avoided English and they avoided like mathematical notation. And they used pictograms to try to describe how we think about hydrogen and use that to define a sense of time, et cetera, et cetera. But, it's hopelessly entangled with our culture and the way that we thought about the atom and all sorts of elements of human culture that there's no way an alien could ever grok. I did an experiment. I took the Pioneer plaque and I gave it to a bunch of physics grad students. So these are humans. They have the same biology, the same brain, the same culture as Carl Sagan. They're even physics students, right? So they have this stuff in their minds and they had no idea. They're young enough to have not seen it before. They had no clue what this thing was describing. So the chances that an alien gets it and figures it out, I think it's pretty slim. I talked to a philosopher of language, and he said he thought it was impossible to decode a signal without common cultural context, without something in common. And if you look at the history of trying to understand human languages, which should be much, much easier than understanding an alien language, we see the same thing emerge. Like, how did we decode Egyptian hieroglyphics? Well, we had a cheat sheet, first of all. We had the Rosetta Stone, which we're definitely not going to have in the case of aliens. But even then, we struggled. It took 20 years to figure out how to map between the two languages. And we had an example of already translated example. Why did it take so long? Because we had made some incorrect cultural assumptions. People assumed that hieroglyphics were pictograms, that if it had something about a bird in it, then it was about birds. And if it had a little thing of water in it, it was about water. It turns out not to be true. It turns out that the Egyptian hieroglyphics encode sounds. It's phonetic, like a lot of other languages. And they only figured this out because they were looking carefully at the translations between the two languages, one of which they knew, and they deduced this. So that's an example of like really requiring a lot of cultural clues to crack a human language. And there's lots of other examples of human languages we have not cracked. These are from like biologically identical people living on the earth whose culture we have a lot in common with. We still can't crack, like Etruscan, for example, despite having lots of examples. So the chances of decoding an alien language with no cultural context without an alien here, I think it's very unlikely. The other scenario, though, when the aliens arrive, that I think is pretty promising, because then we can do stuff like point at an apple and say apple and point at two apples, and we can build up some primitives there because we'll have a physical context in common. We'll be in the same space-time, and we can point at stuff and associate those arbitrary symbols with something real that we can share. So I think that's the only way forward. And so I hope the aliens decide to visit us rather than just to message us.
Yeah, absolutely. But visiting us is hard. And visiting them is hard. And first you have to know where they are. But let me ask you this. Now, basic mathematics, we say two apples. And you can, I think, take most humans on Earth and put four apples on there, and they know that there are four apples there. Do you think that numbers, basic numbers, and I'm leaving out the idea of base 10 mathematics, which is probably not universal, but just basic numbers, do you think that that would be a commonality with an intelligent alien civilization where they would look out and they say, well, you have, a sun and 8 planets? And do you think that is a basic commonality?
I think it's tempting to imagine so, and a lot of people think it is. And there's lots of good arguments to suggest that math is something fundamental to the universe, not something that's just a human mind conception. And parts of those arguments are things like, well, math has led to discoveries. If you look at like how Maxwell put together the Maxwell's equations of electrodynamics, he put those together and he noticed that there was a lack of symmetry. He's like, this would be more beautiful, more mathematically symmetrical if there was another piece here. And then he went out in the universe and he asked, well, is that real? Is that piece there? Is the thing that piece would describe, is that part of the universe? And he discovered that it was. So in that case, like a search for mathematical simplicity and symmetry led him to discover something about the universe itself. Or think about like abstract algebra. These are games that mathematicians invented to play with patterns and like have fun nerding out about patterns and numbers. And they didn't care if it was relevant at all. They just liked numbers and patterns. 100 years after they invented them, particle physicists were like, oh wow, this little cute bit of math is exactly what we need to explain the relationships between all the particles. And it simplifies everything in this glorious way and shows us the path forward and leads us to the Higgs boson. That's math leading physics. That tells us that there's something mathematical about the universe itself, right? And I think almost everybody who's studied physics has had this moment when you see the beauty, the power of the mathematical expression of physics to describe the universe so precisely, down to like 10 decimal places. You can predict the magnetic dipole moments of these particles and get it right. That really strongly suggests that we're seeing the source code of the universe, not some description of it, some approximate, that this is the rule the universe uses to calculate what happens to these particles, right? So it feels very compelling. But you got to be skeptical of that, because that kind of argument puts us at the center of the universe. It makes it sound like the way we think is the way the universe thinks. And boy, that's too flattering to not invite some skepticism. And there's a bunch of people who argue that, numbers could be very, very useful, but they don't have to be necessary to understanding the universe. There's one guy named Hartree Field who did this incredible exercise. He said, let's see if we can develop a theory of gravity without any numbers. So his book is called Science Without Numbers. Totally blew my mind. He says, let's get rid of the number line. We don't need it. It's an abstraction that we created because we like to think that way. Just think about comparisons. This is bigger than that. This is smaller than that. Think about relationships. Don't put everything on the number line to have a value. Just think about bigger and smaller, closer and further. And he was able to construct a theory of physics without numbers, without math, without equations. It's incredible. Now, it's ugly. It's not very useful. You wouldn't want to use it to do any calculations because it's very cumbersome. But it proves a really important point, that many elements of our science could be very handy, could be very effective, could be very powerful, but they might not be necessary. And that opens the door to aliens maybe coming up with other ways to find shorthands and languages that are very compact and effective to describe the universe. So that's exactly the kind of crack that makes me think, it's not necessary to do it this way, so how do we know aliens don't do it another way?
And we have to give a nod to the chemists, because they came up with their entire own system in chemistry of configurations of molecules and things like that mathematical in its way, and involves math, but it's a different expression, in that sense. And that worries me.
As much as I hate to give credit to the chemists, you're right.
Yes, we must give them credit. We'll credit Mendeleev. How about that? That way we're between physics and chemistry. My question is this, though. Can you envision alien methods of communication so different that they communicate chemically, naturally, and so that if they send us a message, it's just chemistry, but we don't have any guidebook on how they express chemistry.
Yeah.
And that sort of plays into this with the numbers, is that, maybe they express it in a completely different way, as you explained. So that's one thing that worries me, is that we have our measures, our weights and measure systems, and those are not going to be universal.
Yeah, absolutely. And, definitely all of our fundamental constants that we measure in terms of our units, those are definitely not fundamental. Like, you wouldn't want to communicate the speed of light in base 10 in meters per second to the aliens and imagine that they're going to recognize that, because they're not going to have base 10 necessarily, and they definitely have no idea what a meter is or what a second is. But there are some fundamental constants to the universe that are unitless, right? That are dimensionless. And those are better candidates, I think, for things that the aliens might have in common with us. But again, it assumes that they have numbers, that they think about the universe mathematically the way that we do. And it would be amazing if they did, but it would also be much more amazing if they didn't. It opens the door to lots of other fun questions, like how do we know that the aliens are even curious about the same things that we are? Like, maybe they're much more into chemistry than we are, but maybe they just look at the universe, which has this overwhelming complexity, this overwhelming amount of information that's coming into your sensorium every moment, and they filter out different things, and they ask questions about different parts of it, and they ignore other parts of it, because you're not experiencing everything that comes in from your senses. You're picking and choosing. You're weaving it together into a story that makes sense to you based on what's important to you. You're ignoring the leaves on those trees and that little bug over there because it doesn't matter until all of a sudden maybe it does, right? And so there's a lot going on in how we interpret the universe and where we ask questions that we don't really know where the boundary is. How much of this is humanity imposing itself on the universe, and how much of it is things naturally emerging from the universe itself that in a way that would have to emerge also for aliens?
I think also that there's a lesson to be learned, because you mentioned Helen Keller in the book, that she had a different sensory experience than the rest of us. And as a result, had a little bit different of a viewpoint. And there are people that have existed, mathematical geniuses in the past, that saw numbers in terms of colors and were able to do extremely complex calculations off the top of their head that would take the rest of us, a computer or a calculator, to do. But it's only because they perceived it differently. And that's another one that worries me, is that if you have an intuitive civilization that doesn't even need to calculate anything, they just see the number. It's natural to them. I would not want to meet such a civilization in the depths of space, because they are probably way more advanced than anything we can do. So is it possible, let me ask you this, that we're slow, and that maybe intelligent life in the universe is just so beyond what our faculties right now are? Just say they have artificial intelligence, AGI, or something like that, we wouldn't even know what to look for. What would we look for with such a civilization? It could just be a nanotechnological cloud floating in deep space or something like that. Something, as Arthur Clarke said, indistinguishable from magic. What's your view on that?
I think that's a really important point. And I think that's why this is such an important question, because the more work we do now to broaden our sense for what's possible, for what alien life and intelligence might be like, the better informed we are when we go to search for it. If you imagine that like human life is the only possible kind of life, then you would do silly things like land on Mars and look for humans. And obviously nobody should do that. You should land on Mars and look broadly for all sorts of weird things, especially the surprises, which means you need to anticipate them. You need to have probes that can pick them up. You need to know how to look for them. In the same way, physicists need to think about ways aliens might be perceiving the universe and interacting with it, interrogating it, explaining it, so that if we do get to meet aliens, we're prepared. We're a better match for those alien scientists. We have a better chance of finding them in terms of like their signatures they leave in the universe, and a better chance of getting to talk to them and understanding what they're doing. And what you said earlier really makes me worried also. Like, what if the aliens are just crazy advanced? Because the universe is old, right? Our civilization is young. Our species is young compared to the age of the universe, billions of years. We know that the molecules necessary for life like on Earth have been around for billions and billions of years. So it's not hard to imagine that alien civilization could be billions of years old, right? What would they even be like? It's hard to even fathom what they would understand about the universe. And a natural question is to wonder, like, are we smart enough? Say, for example, aliens show up, they're smart, they're friendly, they're patient, and they're generous. Best case scenario, right? And they want to tell us the secrets of the universe, how it all began, what it's all made out of, how it really works deep down. What if we're just not smart enough? What if this brain, which developed to stay warm and dry and fed on the savannah a million years ago, can't handle 27-dimensional math or whatever it is they're doing? That would be so frustrating. What a sad trombone to end the journey of science. So that's definitely a possibility and something I actively worry about, because it would be so frustrating to end up with the secrets in front of us, but not being able to grok them.
That's a big problem, especially in terms of what we don't know in physics. All we know is that we don't know. Yeah. And for a very, very large part, it's like having, it's like this. It's like quantum mechanics. We've got one puzzle piece. General relativity, we got another puzzle piece. Mm-hmm. We know there are puzzle pieces missing that link the two, but we don't know how many. And we don't really, I would actually hazard to go as far to say that we might not even know where to look for those missing puzzle pieces. I mean, there's ideas, but those ideas change. And if you look at what science was like a century ago, people were still talking about a steady state universe. Well, now 100 years, just 100 years later, a lifetime, we know that that's completely untrue. Yeah. and likewise, Newton in 1715 or whatever would have never even thought, although we did have a few ideas that something wasn't quite right, but that general relativity would come along and special relativity. Mm-hmm. So these ideas that come out of nowhere, do you think that as we progress as a particle physicist, what will be most amazing are the out of left field surprises like general relativity was? Do you think that's how we will progress and actually figure out more about the universe than we would if we keep messing around within paradigms of how we think about things right now? In other words, quantum theory of gravity. We need a quantum theory of gravity. Well, maybe you don't. Things like that.
Yeah, it's a great question because it highlights something fascinating, which is that we have a particular path through science, and we don't know if that's the only path. Like, imagine, we'd like to think about how aliens might have investigated the universe. Would they end up asking the same questions in the same order? Is the whole thing like the game of Civilization where, you progress through technology in a sort of linear fashion? Or are there lots of ways through the universe? And are we on a good one or a bad one? Are we stuck at this issue of quantum gravity because we did this awkward thing of inventing quantum theory and general relativity separately, right? And then trying to merge them together, which maybe doesn't work. And we ended up down the wrong path. It's even fun to imagine how alternate Earths might evolve. Like, imagine running the experiment of Earth 1,000 times. Would we always end up here? Would we find better paths, worse paths? We don't know. There's so many moments in the history of science that rely on accidents, on chance happening. So it seems like the path that we took depends on a lot of little things happening. For example, it was rainy one weekend in Paris. So some guy, instead of doing his experiment he intended to do with uranium and photographic plates out in the sun, he put it in a drawer over the weekend because there wasn't enough sun in Paris. And when he came back on Monday, boom, he discovered that his plates had been irradiated even though there was no sun. And there's the discovery of radioactivity, quantum mechanics. That could have happened 100 years earlier, right? Anybody had that technology around. It was just luck that he did it. He could have done it earlier. What if our civilization had discovered quantum mechanics a century before? What if we were 100 years deeper into this mystery of quantum mechanics? What if Einstein, as a kid, had been taught quantum mechanics? Would he have still developed like a classical theory of general relativity, or would he have gone straight to quantum gravity? Who knows? Who knows? Maybe the aliens didn't get stuck this way at all. Maybe we're the only ones in the universe who took this particular path. So yeah, I think that the path forward is filled with chance, happy accidents of people connecting things or accidentally doing experiments they didn't even intend and then realizing it teaches you something really deep about the universe. I think that's always the way the universe has shown us the answer, is through these moments, these zigzag moments where we bump into something, realize, oh, hey, this is important. This tells us the universe is pretty different from the way that we expected, which is the lesson again, is to challenge your intuitions. Look at the things you're assuming to be true and wonder if one of them is just something you believe because it feels natural, not because it has to be that way. And, that I think is the greatest opportunity with meeting aliens, is that they might have a different set of those fundamental assumptions. But I suspect that their path through science is also random, that they've also had the experience of accidentally discovering something deep and fundamental that changes completely the course of their investigation.
You can play with all sorts of ideas there. The cave painter 50,000 years ago, it's like, asked the question, what's sticking me to this ground? Mm-hmm. And all of a sudden he's like, oh, it's a graviton. Now, on that,
I love that.
In that grain, what is your view on the graviton? Because that gets into where we're talking about the unknowns, and we don't even know if that's a particle. So, as a physicist, do you think that the graviton exists, or is it just something that isn't a force of nature? It's something else.
Yeah, it's such a deep question. The graviton is an attempt to explain gravity in terms of a quantum theory. And that sounds like a good idea, because everything else we experience is a quantum theory. Electromagnetism, the weak force, the strong force, these are all quantum theories, and they all have these quantum mediators, the photon, the W, the Z, the gluon. That's the way we explain forces at a distance, is that they're mediated by these particles. And so it's so tempting to roll up gravity into that same story and say, hey, there's got to be something there. And we even have a name for it and some mathematics that describes it. We know it has to be a tensor field. That would be the graviton, but there's no evidence for the graviton. And there's, good arguments to suggest that gravity can't be rolled up into those other fields. For example, gravity doesn't cause acceleration. Like, you have all these other forces of electromagnetism. You get into a rocket, like a SpaceX rocket, and they fire their chemical rockets. That's electromagnetism. That's pushing you up away from the Earth, and you can measure that acceleration. You have an accelerometer with you in the rocket. You can measure the acceleration. You can tell you're being pushed against the floor, right? Or against the straps. But gravity doesn't do that. If you jump off of a cliff or fall in towards a black hole, if you operate just under the influence of gravity, you feel no local acceleration. You have an accelerometer with you, and it will always read 0. So gravity will move you, and it can curve you through space, but it never causes acceleration. And that's the thing that makes me wonder if it really could ever be described by a quantum force. It feels to me like really a very different kind of thing, not something we know how to marry. But I'm curious what the aliens think about that question. Maybe they figured it out.
Maybe they did, and maybe they say, well, we know, but we're not telling you. And that would be, you want a maddening alien scenario, there's that. Now, let me ask you this. Now, there are some more out there theories, and I don't want to say out there, actually, just some ultra theories in physics about the nature of gravity, that it may be leaking into our universe from a parallel universe. Thoughts on that?
Yeah, this is really fun to imagine some larger context that could explain some of these deep mysteries. But, if gravity is leaking into our dimensions, then whatever's creating it is sharing space with us, right? That's what gravity is. It's telling us about the curvature of space. And so whatever is bending that space is in our universe. And so I quibble a little bit sometimes with this idea of like a parallel universe. Like, people wonder if dark matter is in a parallel universe and its gravity is leaking over. And, if we're feeling its gravity, then it's in the same space that we are. Bottom line. And so gravity is something that happens within space. And so, there could be new dimensions of space, like we experience these 3, and it could be that there are additional dimensions of space, ways that space has extents that we aren't familiar with. And there could be kinds of matter that are in those dimensions and don't exist in ours. And so you can only see them when you slide over in this new dimension. And gravity could certainly be, it could be affecting through those dimensions. And so it's certainly possible that there's more to the universe that we can experience and there's more out there that we know about, and it could also explain gravity. One of my favorite explanations for a mystery of gravity, like why is gravity so weak? The other forces are really powerful compared to gravity. You can overcome the force of gravity very easily using like a fridge magnet, which has like a very small amount of magnetism, but it overpowers the gravity of the Earth. Why is gravity so weak? Well, one of the explanations is that it's not actually that weak. It's just that it feels more dimensions of space than the other forces do, and so it spreads out more quickly, it gets diluted more quickly. And so from a gravitational point of view, things are sort of more distant than they are from a magnetic point of view, and that's why gravity feels weak. And so that's like a really cool explanation for why gravity might be weak, but there's no evidence for that. So far, these theories are, as you say, sort of out there. They're creative ideas. They're ways we're thinking about trying to break the mold and investigate how the universe might really work. But there's no concrete evidence for any of them. There's no experiment we've done that violates our current theory of physics from that point of view. So they're fun ideas, they're very creative, but who knows if they actually describe reality.
Some of my favorites were John Wheeler's ideas, like the one electron universe and things like that.
Yeah.
But the thing is, those thought experiments are useful because they're just like technosignatures, trying to imagine alien technosignatures, because it gives you some indicator of what to look for. But let me ask you this now. If the graviton exists,
yeah,
say it actually is a force-carrying particle of some interaction of some sort, and that there is a quantum theory of gravity.
Okay.
If it is that, what happens if the graviton obeys the double slit experiment? And does that mean that we can manipulate gravity?
Yeah, exactly. That's why this question of quantum gravity is so interesting, because we want to know, is gravity quantum mechanical? Can gravity interfere with itself? Can it maintain a superposition? That's the thing that quantum objects can do, is they can maintain the possibility to be in two different states, and then those states can interfere in creating crazy stuff like the double slit experiment. If gravity is fundamentally classical, then it can't do that, and it collapses those wave functions by interacting with it. But if gravity really is quantum mechanical, then it can maintain a superposition, and then you get really weird stuff, like you can have space have a probability of being curved instead of actually being curved. Like maybe space over here is curved, and maybe space over there is curved. That'd be super strange. You can get all sorts of new weird interference effects, sort of like the double slit experiment, but in space-time. And that would be bonkers. Nobody's ever seen that, but there actually are some really cool experiments people have come up with recently to do like tabletop tests of quantum gravity to see if there are these kind of quantum gravity effects. One of them involves like dropping pairs of diamonds and having them be quantum entangled with each other, and then seeing if the gravitational force of the falling diamonds breaks that entanglement by collapsing that superposition. Really hard examples and experiments to do, because you have to measure like the gravitational forces on tiny little flakes of diamond, which is experimentally very, very challenging, but could answer these questions of whether we're seeing gravitational quantum interference, which nobody's ever seen before. And yeah, as you say, would really change the way we think about the nature of space-time, and might open the doors to really awesome applications. And that's, of course, what we're curious about, not just like how does the universe work on a fundamental level, but will it let us like get off this rock? If we could figure out that the universe is quantum gravitationally, could we use that somehow to develop wormholes and warp drives and let us go experience the rest of the universe and get to talk to some of these aliens? Maybe we could actually attend the first interstellar physics conference.
I wonder what they would serve for lunch at such a conference. Now, quantum non-locality. We know that we have a problem as far as how we view locality. In other words, we look out into the universe and we see distance, lots and lots of distance. But quantum entangled particles do not seem to see that distance. It's just that they can't transmit information, useful information. Due to quantum entanglement, though, do you think that there is a path to at least think about the idea of quantum communication that is instantaneous in the universe, or do you think that the universe will continue to forbid that?
Yeah, great question. And I just had a long conversation with Sean Carroll on this exact question on our podcast, Daniel and Kelly's Extraordinary Universe. Go look it up if you like. It's connected to these two questions of locality and causality, which are two fundamental assumptions we make about the nature of the universe, right? The things have to be near each other to interact, and that effects propagate at a finite speed. And so like you can't affect something across the universe instantaneously, or that there's a time ordering, right, to events, that A follows B from C, from D, etc. But we don't know. And as you say, some of our theories of physics seem to be struggling, and people wonder if we need to give up on one of these assumptions. And you're absolutely right that quantum mechanics tells us that something non-local is happening, right? That no matter how you interpret Bell's experiment, something non-local is happening. I think it's widely misinterpreted to suggest that there's no hidden variables, but really those experiments of the entangled particles at a distance, they tell us there's no local hidden variables. And so one possibility is that these two things are somehow coordinated over space-time. The quantum mechanics is just fundamentally non-local, right? That the collapse happens in an extended way, instantaneous across space-time. Another possibility is that there are global hidden variables. These things are determined, but not locally, right? Like a Bohmian mechanics pilot wave kind of theory. All of this is bonkers and really hard to wrap your mind around. But your question is like, I think this might allow eventually some sort of instantaneous communication? I mean, that would violate special relativity and general relativity. So it's pretty hard to wrap your mind around that. But we also know that these theories don't play nicely with quantum mechanics, and that something has to give. And so I keep an open mind. I think it's certainly possible. And a lot of what we think is fundamental about the universe could just turn out to be emergent, could just turn out to be like approximate rules that describe the things we've seen so far, but aren't fundamental to the universe. The way that like Newtonian gravity is an emergent description of motion that mostly works, but isn't fundamentally telling the truth about the universe. It could be that there is a deeper truth to the universe that is not local or not causal, and that locality and causality are things that are accidents or, just sort of circumstantial, and that might let us escape some of these rules that we thought were hallowed fundamental principles of physics, like special relativity and, the forbidden nature of faster than light communication. So that's a long way of saying, yeah, I think it's possible.
I always keep in mind, though, we call them theories, the theory of relativity, but that's not really the case. They really are descriptions. And it was Einstein describing the behavior of the universe. But we know that that breaks down in both at quantum mechanical scales, but also inside the event horizon of a black hole. So it's incomplete. And just as Newton was incomplete, he wasn't wrong per se, he was just incomplete.
Yeah.
And do you foresee a complete theory of physics coming anytime within the next 300 years? I mean, what is your sense of the wave of physics right now? Do you think we're closer? Do you think we're very far away and we really need aliens that speak physics to come and tell us?
Well, we have no idea, right? That's the problem, is we've explored the universe down to a certain scale, and that theory is very successful. But as you say, very, very strong hints that it's not fundamental, that it's not the end of everything, because we have no single theory. But the problem is that we have no clue whether that just goes on forever. Like the theory that we're describing is an emergent effective theory of the universe. It works, as you say, approximately under these conditions, and we think it breaks down. And that's true of every theory we've ever had. And it might be that that's all there is, that, there is no true fundamental story out there. It's just like a tower of effective theories that work in certain conditions and then break down, and then you got to go to a new one. And that's what we see. You can't, for example, use particle physics to explain the weather or use fluid dynamics to explain basically anything else. We have all these descriptions of things that happen, and it's wonderful and beautiful and it's incredible they work at all, frankly. But why these like simple stories emerge from the underlying chaos is not something we understand. And so we can't philosophically say anything with confidence about what's going on underneath. It's possible to do things and to describe the flight of cannonballs and the flow of fluids without understanding fundamentally what the universe is made out of. And that's essential to making any progress, that we can sort of decouple from the fundamental truth and still get something done. But it means we have no guarantees that there is a fundamental truth. And there's a very widespread, I think, popular misconception about the fundamental layer of reality, this idea of the Planck scale, that there's a distance below which, distance doesn't mean anything anymore. This is the pixel size of the universe. And it's just not. It's said very often, and so it's understandable for people to have that misunderstanding. But the Planck scale is just what you said. It's where quantum mechanics and gravity come into conflict. And so we know that our theory doesn't work past that scale. It's not a statement that nothing happens past that scale, or that's the fundamental layer of reality. The universe could be much more fine-grained than that. It could go on forever, just theory upon theory upon theory upon theory. There is no guarantee that there is a bottom at all. And so when we think about the future of physics, I suspect that we will keep developing theories, and they will be supplanted by new theories and supplanted by new theories, and we'll keep working on our tower of effective theories. And we may one day get to some theory that we don't supplant, that we never find it break down. That doesn't mean, unfortunately, that it's fundamental. It just means that maybe it breaks down at some crazy high energy we can't reach, or under some conditions we can never create. You can never be guaranteed that something is fundamental. You could prove that it's not. You can show that it breaks down, but you can't prove that something is fundamental. I think the most convincing thing would be if we arrived at some theory we suspected was fundamental, and then the aliens arrive and they had reached the same theory. That would be, a strong argument in favor, but still not convincing proof. But, this whole thing makes me worry that a lot of these effective descriptions we've concocted about the nature of the universe, our human tower of explanations, they might not even line up with the alien tower of explanations. We might have a completely different way of breaking up this incredible, chaotic, buzzing universe into understandable chunks. It might be that the way we see simplicity emerging from this chaos could be a product of our minds, not just a product of the universe.
Let me flip that around. Mm-hmm. So instead of thinking in terms of 1/6000th of a Planck length, what if there is a pixel? Would it disturb you? In other words, if there actually was an arbitrary fundamental pixel that we were to discover a limit in quantum mechanics, which I would say probably not, because it's what you were talking about, things like the quantum foam and everything that goes on. But if there were, would that disturb you? Would you start questioning reality and say, you know what, I'm giving up physics because this is all an illusion?
Right, yes, and is it a simulation? I think that's sort of the goal of physics, is to reveal the fundamental nature of reality. My fantasy is that we dig deep and we discover something, and we have a simple explanation, and the parts of that theory are straightforward and not complex, and that there's something about that theory that's beautiful in a way that convinces us this is the only way it could be, that there's only one mathematical way to express this concept. And that's sort of the goal, because then you're looking at nature laid bare, right? You're looking at the fundamental bits and bobs of the universe philosophically. And then you get to do the fun bit, which is saying, well, what does that mean about the nature of the universe? What does it tell us about why it's here, and why anything breathed fire into these equations? And, one fun and very popular idea is this one that we're living in a simulation and the whole thing is a big computer. And I think that's fun, but I think actually it's not imaginative enough, because it makes a bunch of assumptions that if we live in a computer and in a simulation, then that simulation is running on a computer in some meta universe, right? Not in our universe. Our whole universe is like Super Mario Brothers in some other universe. But we don't have to make any assumptions, or can't make any assumptions about the laws of physics in that meta universe. The way there's like no relationship between the rules of Super Mario Brothers and the laws of physics necessarily, right? You can make any video game you want. There's no connection. So we don't know anything about the laws of physics in that meta universe that our supposed computer is running in, which means we don't know anything about the nature of that computer. Right? The nature of computers in our universe, analog computers, digital computers, quantum computers, come from the laws of physics. A computer is a way to like rearrange the universe to force it to use the laws of physics to do some computation. It depends on the laws of physics. So if we don't know the laws of physics in the meta universe, we can't know anything about the nature of computation in that universe. So we can't like look at our laws in physics and say, oh, this looks like computers we build, right? Or the way that we write simulations. We don't know anything about the meta people and the meta simulation and the meta laws of physics. I think it'd be much more interesting if that's just very, very different from the laws of physics that we have. But ultimately, like Super Mario, I don't think we can ever know, right? He has no way to learn that he's in a video game. And so in the same way, we just got to do what we're doing and dig down deep into the nature of reality and try to understand it and then ask those philosophical questions like, what does this mean? And that's why I'm so excited to talk to aliens about it, because I hope that they can launch us forward in the future and give us clues about this, or that they've asked different questions and they help us back up and go down the right path. And that's why it was so much fun for me to write this book, to think about other paths that humans haven't taken that might be more fruitful.
Yeah, but it could be disappointing. You could find the aliens to speak physics, and you could sit there and talk to them, and they're really apathetic about it, and they're like, yeah, you see all this around you see all those stars. This is the fever dream of a Boltzmann brain that is in another universe. Woke up, everything was dead in that universe, so it just made one up, and that's what we live in. So, what would be the first thing you would ask if you came in contact with an alien, other than what are the laws of the universe? What do you know? Those are the natural questions scientists would ask. But what would you ask them about their culture and what they do and where they came from?
Yeah, wow, great question. I mean, we're skipping forward beyond lots of hard problems, right? How do they get here? How do we establish communication? And I would not want to be one of the first people to talk to the aliens, because I'm a wimp and I don't want to be eaten for lunch. But if somebody else does figure that out, and then I have a chance to sit down with them, then I've decided to spend my life asking the question, what are the fundamental elements of the universe? I'm a particle physicist. I smash stuff together. I want to discover that. And so that's my question. That's everybody in science. This is what I love about science, is that everybody picks their question and devotes their lives to it. There's somebody out there right now sloshing around in wet socks in a rainforest looking for spiders because they decided to devote their life to understanding those spiders. And somebody else who's freezing their butt off looking through a telescope, and people building colliders, because science is a human thing that comes out of our curiosity. It's very personal. And for me, the question I want to know from the universe is just that. It's like, what is everything made out of? Why is it this way? Could it have been another way? And so if I had an opportunity to, talk to an oracle or speak to super advanced aliens, that's definitely going to be number one on my list. I think number two would be like, how did the universe begin? I think knowing for a fact the first few moments of the universe, or if it had a first few moments, or if it's, been around forever, would have so much philosophical context, would tell us about the nature of our existence in ways that are really, really meaningful and could change the way people feel about their lives. And that's why I think physics is so exciting, because these questions, if they have answers, those answers have such deep meaning, such powerful contextual clues about the nature of our existence. And that's what it's all about. But, that's the kind of thing, that kind of emotional response you're hearing is the thing that makes me wonder how much humanity is in our physics. Are we making these choices because of the kind of weird, curious creatures we are? And how much do we have in common with the aliens scientifically? It feels like there's a lot of humanity in the questions we're asking, the approaches we're taking, the answers that we accept. So that's the thing that fundamentally makes me curious about alien science.
And it worries me because animal intelligence, we can't communicate with an orca very well. and we don't know what they tell each other.
Yeah.
How do they communicate? We just know that they are able to plan and work in concert, so they're communicating somehow.
Yeah.
If we can't figure out our own animals, then it's going to be very, very difficult to figure out an alien.
Yeah.
Now, in the context of alien civilizations, though, and communicating with them, what would you tell SETI from your particle physics standpoint? Can you interdisciplinary think of ways that SETI might be able to come up with technosignatures or ways of communication? So we send out the Arecibo message again, which, by the way, that when they formulated that, I think it was Frank Drake, I'm not sure, but somebody sent out the Arecibo message to like 20 scientists, and only one of them figured out the very most basic part. Only one of them. The rest of them didn't.
That's so disappointing.
And it's a figure of a human on a radio telescope. But, well, you know what? That actually brings up an interesting question. So, say you're communicating with aliens via radio signal. Mm-hmm. There really are only a few ways you can build a radio telescope, right? So you're going to know what a dish is if you can even pick the signal up. So there are certain things that perhaps the laws of physics in the universe impose on us as far as equipment goes that requires that. Do you think there's commonality there in that certain technologies require certain things or they won't work?
Yeah, I think that if they're broadcasting in electromagnetism, we probably have a lot of that technology in common. But as you say, who knows? Like maybe they're sending us messages via neutrinos. Neutrinos are a great way to communicate because they go right through everything. Unlike electromagnetic signals, which some frequencies pass through gas and dust and some frequencies don't, neutrinos pass through everything. And so that makes them hard to pick up, but also pretty hard to stop. So it's possible that we're getting messages in neutrinos. We just can't see them well enough to detect. We need to build like a planet-sized neutrino detector to be picking up on the galactic neutrino radios. You know, who knows? What would I tell SETI? I had a fun conversation with Jill Tatar about SETI and how they're looking for signals. And I think they're doing a great job. You know, they're being really broad about the kind of things they're looking for, not just electromagnetic signals, but like weird artificial things. Like, is that star blinking on and off in a weird way, or all sorts of stuff. So I think that they're doing their job. And I've been also really impressed with how interdisciplinary they are. They have conferences where they invite anthropologists and linguists and philosophers to question them and to help them break down their barriers about what interstellar communication might be like, or whether it's possible, or in what ways we should be pushing on those barriers. So I've been pretty impressed with the SETI community and how broad-minded they've been thinking.
Very robust. I mean, you can go back, starting with Cocconi and Morrison and onward, which that's been, 70 years, that they've really put a lot of thought into it. And when you have people like Jill Tarter and all that involved, it's like they've thought this through many thousands of times every day. Yeah. You know, what to look for and what to deal with, which I think radio is absolutely worthwhile because that's a low hanging fruit. Yeah. And I personally, my view, and you may differ on this, so we'll kick this around. I think radio is like fire. Humans fire predates us. Other hominids were using fire and making tools, and we inherited that. And yet we live in a world where there are more fires, artificial fires going. Yeah. Everybody has one in their house, effectively. So fire never went obsolete because it's a property of nature. It's a property of chemistry. Therefore, radio may never go obsolete. Thoughts?
Yeah. I think it's likely. I think we'll probably be using radio or some kind of wireless communication for a long, long time. It's hard to imagine something supplanting that. On the other hand, it's fairly recent, right? We haven't been using it for very long relative to how long we've been on this planet. Stone tools had a pretty long day compared to radio. So it could be that we discover something else more powerful. But the thing about radio is that it's easy, right? You know, it's plentiful, it's cheap. It's like you say, fire, even though it's been replaced in many contexts, it's still around because it's easy and simple and basic, and it's a product of our environment. So I think that's likely, but I don't know if it's likely in other contexts. You know, what if aliens evolve on a planet where, you know, they have a star that's very, very noisy in the electromagnetic spectrum, in the radio spectrum, and so like listening to that is just like listening to constant screaming. And so they never develop a useful technology there because it's just not the right environment for radio. Or you could imagine aliens developing where they naturally have a sort of telepathic radio sense, right? Like where they can communicate from brain to brain using radio, where they basically have biological antennas in their minds. It's not even that hard to imagine how that could evolve. It's a little bit surprising that it didn't, though. I'm no evolutionary biologist. So I can imagine the full spectrum of alien experiences, from like radio is useless because the environment is swamped with it, to we have built-in telepathy. And what would that even be like? And would they develop language? Would they even think about ways to communicate with us if they don't have to do this symbol translation? If they just like go directly brain to brain, it might be difficult for them to even conceive of what communication is because it's just part of their experience.
Is there any evolutionary reason for that you can think of? I mean, I'm certainly not an evolutionary biologist here, but why can't anything on this world perceive radio? Because you look at bees, they can see into the ultraviolet, and there are species that can see into infrared, and we can feel infrared, we can sense it, but nothing that I know of on this planet has any clue that radio exists. We didn't know until we understood electromagnetism. Can you think of an evolutionary path that would actually yield that?
Yeah, radio is tricky because you need kind of a large antenna to see long wavelength radio. But, if you push up into the shorter wavelengths, it's still invisible. And like your cell phone uses a wavelength that doesn't require a massive antenna or even a large amount of metals. And so it's not hard to imagine developing that kind of biological technology. So no, I have no idea why. I mean, it must have some sort of evolutionary expense to it, or maybe the precursors are not useful. Yeah, it's a great question. Maybe because the universe is, unlike photons, like the universe is not already loud in radio. Maybe if we were naturally emitting radio, then predators would have developed a sense to pick that up the way they like. As soon as critters got big and loud on this planet, then predators and prey both developed a sense of hearing. It's pretty recent development on this planet. So maybe only if we were naturally creating it, if it was like obvious information that was out there, would we then evolve a sense to pick up on it? So maybe because we're naturally quiet in the radio, that's why we didn't develop an antenna inside our minds to communicate via the radio. But it's just a guess.
Yeah, and there's also atmospheric makeup and what your atmosphere blocks, and things like that. Many questions about what you can see. But there is an elephant in the room. We were talking about neutrino communications.
Yeah.
And how hard they are to stop and detect. But you can, which actually adds to the mystery of dark matter. Why aren't we seeing that in the giant pools of water? We're not seeing that.
Yeah.
So even weirder. But the question is, what about gravitational communications, using gravitational waves? If you can harness gravity, and you don't have to, you can send a message without slamming two black holes together or having them orbit each other or whatever you would need to do to send out a gravitational message.
Yeah.
It's going to go through everything just like a neutrino is, maybe perhaps even more efficiently. So in that sense, do you see any fruit that might come from gravitational wave communications and doing steady searches in that regime as we become more capable?
100%, I want us to be listening to gravitational waves and looking for alien signatures. Absolutely. It's definitely a fruitful way to listen to the universe, because every time we develop a new kind of technological sense, we always learn something. Like maybe it's just cool astrophysics, but maybe it's going to be aliens. And so it's incredible that we have this new technological sense. We've like extended our sensorium into this new regime that we absolutely were blind and deaf to before. So that's very exciting. But do I think that it's possible for aliens to send us those messages? Again, we're bumping up on the physics fact, which is that gravity is weak. And so to send a message that's going to go from star to star using gravity, you got to have a really big mass, because it's just much easier to do with electromagnetism. Electromagnetism is like 10 to the 30 times more powerful. You want to send a message that's going to go from here to there. There's a reason that all we've seen so far are like merging black holes, because they are very, very massive. And so they send a signal big enough for us to pick up light years away. And so if you're going to communicate with aliens using gravitational waves, you're going to have to do something like manipulate merging black holes. I can imagine like having two black holes and tweaking them so that we're like sending weird predictable ripples through the gravitational waves. Would be super awesome though. I would love to communicate with aliens via gravitational waves. It would be really an incredible story. And that would be a really fun way to communicate with dark matter aliens, because that might be the only thing we have in common with them, right? But it's like a portal. Gravity touches everything. And so it would be a great way to communicate with beings that exist in another kind of matter that we can't interact with except for gravitationally. So yeah, it's a whole nother way to listen to the universe, and one we should definitely be doing as much as possible.
It would be extremely fun if the dark matter aliens sent gravitational messages to us and it was prime numbers proving that they have numbers. They're just counting them off like the movie Contact, but in gravity.
Incredible.
And that would also tell you that there's more to gravity than we know.
Mm-hmm.
The thing is, though, is it's so incredibly frustrating that gravity is so weak. Compared to anything else. That's vexing. Would you characterize that as the big problem in trying to come up with a theory of gravity as to more precise than what we have? Do you think that's the big problem, is the weakness of gravity?
Yeah, in physics that goes by the name of the hierarchy problem. Essentially, why is gravity so much weaker than the other forces? Anytime we see this sort of like contradiction or misalignment in physics, we wonder why. Like, what's the explanation? What's going on here? And absolutely, it makes it difficult because you have a theory of everything. It has to explain why these forces are powerful and this one over here gets so weak. So it requires more bits to your theory, more moving parts, more explanations, which is always unsatisfying. And what you'd like is a simple, beautiful, elegant theory where everything falls out of it very naturally. And so the hierarchy problem is a huge puzzle in physics right now. How to bring these things together, how to explain why the scale of the weak force is so different from the scale of gravity. We don't have really any great ideas to solve that one yet. Yeah, so that's definitely a big problem.
Infinities in physics, which everybody does not like, but that perhaps is just a matter of comfort. In an infinite universe, it implies that they must be out there, right? If the observations that are sort of suggesting that the geometry of the universe is flat, that suggests an infinity. Do you have a problem as a physicist with infinities? In other words, is it possible that when general relativity starts spitting out infinities inside the event horizon of a black hole, do you see that as a problem, or do you see that as something that it just is?
Yeah, so many great questions there. I think that the universe, as we measure the curvature, is on average 0, which suggests the space is flat. And that's compatible with an infinite universe. And personally, I don't have any problem with that. I think it's awesome. I would love if that was the nature of our universe, if it just went on forever with more stuff. But it doesn't have to be. It's possible for space to be flat and for the universe to be finite. You could have a topology of space like a torus. A torus, it's like a donut, and it seems like that's curved, but actually space is flat on the torus. It's like a cylinder, so it's like a sheet of space wrapped up and then connected at the two ends, but it doesn't actually require any curvature. It's just topological connection. So the fact that space is flat doesn't guarantee that it's infinite, though I would so much prefer an infinite universe. I think that would be super awesome because there'd be so much to discover. On the other hand, it doesn't really matter if the universe is infinite because practically it's finite. It's limited by the speed of light. There's a part of the universe we can see and part of it that we never will see because the universe is expanding and that expansion is accelerating. And so those bits of the universe in space between us and it is growing faster than photons can fly through it, which means we have no chance to experience or interact with those parts of the universe. So for all extents and purposes, the universe really is finite, even if it goes on invisibly beyond that horizon. I don't have a problem with infinity in that sense, but I think that there's definitely a problem with the infinities of general relativity, not just because they're infinities, but because they are in stark contrast to the predictions of quantum mechanics. Like, we know the universe is quantum mechanical. We've seen it, we've measured it, we observe it. And so to make these predictions, to get to the infinities in general relativity, you have to ignore quantum mechanics. Like to predict what's inside an event horizon, you could use general relativity and you could get to infinite curvature at a singularity. But to do so, you have to ignore what we know about the universe. You have to ignore quantum mechanics, and you just can't ignore quantum mechanics. I mean, you can ignore it when you're predicting how Jupiter orbits the sun, but if you're predicting things at really small scales like a singularity, you gotta listen to quantum mechanics. And so my problem with the singularities and infinities in general relativity isn't the infinities themselves, but the fact that along the way you've had to ignore things we know are relevant in order to get there. So I think they're probably not physical.
Got an off-the-wall question for you to add on top of all the off-the-wall questions I've been asking.
Awesome.
So, as a particle physicist, you are going to have a different perspective than my usual astrophysicist and things like that on this. Okay. Do you see, in regards to the nature of black holes, the possibility of another degeneracy pressure? In other words, meaning that black holes overcome that and collapse down to a singularity, but then you have neutron stars and all that, and there's these degeneracy pressures that get overcome, and then they hit another equilibrium. Do you think there's an equilibrium inside the event horizon of a black hole that we're not aware of yet?
I think there certainly could be, because we don't know anything about what's going on past the event horizon, and it could be that there's some quantum effect that's preventing a collapse into a singularity. But I could do even better than that. We don't actually know that there is an event horizon. It could be that things have collapsed beyond a neutron star, but it haven't actually formed an event horizon. It's just some other kind of very dense state of matter, potentially prevented from collapse by some sort of degeneracy pressure, some quantum effect there. We've observed very dense, compact, massive objects. We have no direct verification yet of an actual event horizon. And so it could be that there's some degeneracy that's preventing the creation of actual GR classic black holes in our universe. Or they could just be black holes. We don't know.
But black holes do illustrate something, and this gets directly back to the topic of your book. Everybody should check this out, Do Aliens Speak Physics by Daniel Whiteson and Andy Warner. And the question is this. So the interior of an event horizon, if they exist, which physics, basically everything says that they probably do, right? But observe it. But the question is that inside that, it becomes very ambiguous. It's like detecting alien life. You have to worry about ambiguity, wow signals and things like that. But in this case, it's just ambiguous, like it isn't even a part of this universe any longer. It's something else, which, some people have pointed out looks a lot like a wormhole, but regardless of what it is, it's no longer interacting with this universe. It's somewhere else on its own. Hawking pointed that out, actually, that it's just almost meaningless in a way once you go past that event horizon, because you aren't part of this universe anymore. So your aliens that speak physics, what if they aren't here anymore and they have pinched off their own universes and they go live in that, a better universe than this one? They've custom designed one that's better than this one, because this one's rather harsh. If you're not living on the surface of the earth, it's rather harsh. So they go and they make one that has a whole bunch of habitable planets, and that's actually the better thing. Do you think that that's too speculative, or do you think that that's a possibility in the future of physics, that we might be able to create a universe that's better, that we can escape to when this one burns out, or even earlier than that, and there simply aren't any aliens here, and that the solution to the Fermi paradox is aliens, once they get to a certain technological level, they move to their own universe and don't care about this one any longer?
I don't think anything is too speculative. I think the history of physics teaches us to be very careful about clinging to our assumptions, that we should really question everything at the foundations, because we come with all these biases from our human experience that tell us the universe should be X, Y, or Z, and it's not at all obligated to follow those. So essentially nothing is out of bounds for me in terms of, could it be this way? Yeah, maybe. We don't know. And it's certainly possible to exist inside an event horizon. Like if you have a black hole that's charged and spinning, you can find stable orbits within the event horizon, orbits that don't end up plummeting towards the singularity. And that's even just within classical GR. So yeah, it's possible for crazy things to happen inside an event horizon we might not be aware of until we build our own. Though I don't know why aliens, if they're going to build their own universe, why they would have to do it inside an event horizon. Being inside the event horizon, it cuts you off from the universe, but doesn't like give you access to new laws of physics as far as I'm aware, though who knows, right? Maybe those conditions close to a black hole create opportunities I can't even imagine. That would be the only reason I can imagine you would go inside the event horizon. But yeah, I think it's certainly possible that there's exciting, crazy stuff happening inside the event horizon. And then I'd be faced with a dilemma. Like, what if the aliens are inside the event horizon and they have all the answers and I could just jump in and learn about the secrets of the universe, but then never come back? I'm not sure what choice I would make in that scenario.
Yeah, but that brings up the aliens again, because some aliens may not care about that. And one of the big arguments I always get from people is that, well, aliens don't want to spend 500,000 years traversing interstellar space.
Yeah.
Well, what if it's a machine that can self-repair? It won't care. It doesn't care about the passage of time. And what if the alien being coming from Proxima Centauri comes here at, 10% the speed of light or whatever, some doable speed? It may not care if it lives for 100,000 years. So we place another human bias on this when we think about lifespans, because we only live for 70, 80, 90 years, and that we see it in that lens. What do you think about that time factor, in that aliens may not care about time?
Absolutely. I think aliens could exist on much shorter or much longer time periods. We tend to see the universe in this sort of human time scale, which has held back our science. Why was it so hard for us to understand that glaciers scrape valleys, or that plate tectonics have shaped the world, or that the formation of the solar system took billions of years and was quite chaotic? Because these processes in deep time were really hard for us to wrap our minds around. The same way it's really hard to think about the microscopic interactions, the super fast things that quantum mechanics are doing. There's certain things that are intuitive to us and certain things that will always be alien. And aliens, if they operate on a different time scale, much slower, much shorter, then they could find different things intuitive and different things natural. And that could make it very hard for us to overlap. I do think about the scenario you pointed out, though, like you send an AI probe into space and it takes 100,000 years to reach somewhere. I wonder if an AI probe, though, is going to get bored. If it's a simple computer, then obviously not. But if you put AI in that thing so it can make intelligent decisions when it arrives, it could go crazy on that voyage, man.
Well, that's terrifying, but it's October. It's Halloween season. So what I wonder about in regards to that is this. If it could go dormant or something like that, but what if it takes a few too many hits from cosmic rays and goes insane, and there is an insane von Neumann probe lurking in the solar system, behaving completely irrationally, and we don't even know it's there yet? Thoughts on that? Yeah, exactly. I do worry about the von Neumann machines. If we are maybe a couple hundred years away from having the technology of building self-replicating probes, then wouldn't aliens also develop this technology? And what stopped them? Because we don't see probes consuming the entire galaxy and turning themselves into more probes. So where are they all? I hope that the aliens are being responsible about unleashing self-replicating probes on the universe. Last question for you, Doctor. So you meet the alien that speaks physics, and you ask it what the answers to everything are to the universe, and it hands you two things. Mm-hmm. One, you are here to collapse the waveform of the universe, and two, infinity. How would you interpret that?
Wow, so you're the alien here. Yeah, if I'm here to collapse the wave function of the universe, that says something really deep about the nature of quantum mechanics. There's all these theories about, does the wave function collapse? What causes it to collapse? Is the wave function even real? So that would tell me that the aliens have gone down a very similar path to the one that we have, and they've come to similar questions. And I don't know if I would have to agree with their answers, though. Like, I find it hard to believe that consciousness is required to collapse the wave function, because it makes me wonder about, who was around collapsing the wave function before we got here, when we were still sliding around slimy bits in the sea. So I would definitely argue with the alien about that one. But I'd love to get the message of infinity, an infinite universe filled with intelligent critters, thinking about how everything works. So many fun colleagues to talk to, so many amazing science conversations to have in an infinite universe. And, I'm ready for anything.
I'm not looking forward to the lawsuits of an infinite universe, because that would mean that there are infinite numbers of me, little variations of me out there, and we're all going to sue each other. It's horrid. But Daniel, tell everybody about your podcast.
Yeah, so I'm the co-host of Daniel and Kelly's Extraordinary Universe. It's a podcast about all the big questions in science, everything we're curious about, from like zombie ants to, how blood plasma works, to the nature of black holes and particle physics. It's with my friend Kelly Weinersmith. Go check it out. And the book is called Do Aliens Speak Physics? It's out November 4th. I wrote it with my friend Andy Warner. He's a cartoonist from Berkeley who drew lots of really fun alien doodles to help illustrate these crazy ideas that we talk about, and also to keep the mood a little light.
Indeed, and it was a good book. I read it all yesterday, believe it or not.
Wow, thank you.
And enjoyed it. I really enjoyed the illustrations. That was pretty cool. And there were things, for somebody that's spent the last 40 years thinking about alien life, obsessing over it, really. Mm-hmm. There were some new ideas there. So it's a very good book. I recommend it to everybody.
Appreciate it.
All right, Daniel, thank you for joining us today. And last question. Would you eat the moon if it were made of ribs?
I love me a good rib, so yeah, absolutely.
We'll do that sometime. Thanks, Daniel.
Thank you.
Event Horizon and my channel are now available as a podcast on Apple Podcasts, Spotify, and YouTube memberships. Early ad-free episodes, bonus episodes, and sleep-focused content. Sign up now by clicking the links below to your platform of choice.